Okay, welcome to Jump Math. This is book 2, page 91. We're looking at dependent and independent variables now. And again, this is focused in patterns and algebra. So for question 1, it says the graph shows the cost of making an international phone call with a cell phone company. So here we got cost in dollars on this side, and we've got length of call in minutes. It says if you talk for 2 minutes, how much would you pay? So you go to the 2, follow it up, and then you can see here you're going to pay $4. So again, this is supposed to be answered in your notebook, so please do that not on your work page but in your notebook, and you'd write $4 for A. What's the cost for a 1-minute call? Well, if you do the same thing, it's about $2. How much would you pay to talk for 10 minutes? Well, it looks like this is going at $2 for every minute, so I would expect for 10 minutes to cost $20. So you would continue that pattern and see if you can figure that out. So try out number 2, and you can see the graph is a little bit different on that one. Let's move on. It says in an equation with 2 variables, the independent variable is the input and the dependent variable is the output. The output depends on the input. So dependent means it relies on the input. So let's look at this example. It says, in question 1, the length of the call is the independent variable, and the cost is the dependent variable because the cost depends on the length of the call. Mathematicians usually use the x-axis for independent variables, so you might want to highlight that or make note of that, and the y-axis for dependent variables or other independent variables if that's the case. Let's take a look at question 3. It says, Tom runs a 120-meter race. What are the dependent and independent variables? So the independent would be the amount of time he's running, and the dependent would be the distance he goes. So the longer he runs for, the further he runs. So the dependent variable is the distance, and the independent is the time. Okay? So again, this would be written in your notebook somewhere. So distance is the dependent one right here, and the independent is time. How far from the start was Tom after 10 seconds? Well, you go up the chart here to 10 seconds. It looks like he was 40 meters. So you'd answer that. 25 seconds, same thing, go up the chart and look across. If he continues running at the same rate, how far will Tom be after 1 minute? So you'd have to figure out a pattern for that, and it looks like it'd be 120 meters in 30 seconds. So if we doubled that, if that was 30 seconds, then you would predict somewhere around 240 meters. Let's see how you do with this question about a bike rental. Okay, let's move on. So this is a little bit of review from book 1 if you've already done the lessons there. It says for each table, write a rule that tells how the input changes, how the output changes, and the relation between the input and output. So I like to use I for input and an O with a line through it for output, so it's not confused with a 0. The numbers in the input column increase by 1 each time, so you can see this going 1, 2, 3, 4. And the numbers in the output column increase by 3 each time, so you can see that's going 3, 6, 9, 12. And so what we do to the input to get the output is multiply by 3 to get the output. Okay? So let's look at each of these. One moment. So this is page 92 and numbers 5, A and B. So we're supposed to describe how the input is changing, how the output is changing, and what's the relationship between the input and the output. So first we can see that the input is increasing by 1 each time. That's one statement. we could also say the output is increasing by 6 each time. So what's the relationship between input and output? Is I go the input multiplied by 6 equals the output. Okay? So again, this O meaning output, not 0. Okay? Another example here. What's the relationship? Again, the input is increasing by 1 each time as we go down the chart. What's the output increasing by? It's increasing by 9 each time. What do we know is the relationship between those two then? We take the input number, which in this case if we took 1, we multiply by 9, and that equals my output number. Okay? So the output is input times 9. In this case, we'd say the output is dependent on the input. Whatever the number is we put in the input will give us a value for the output. Okay, let's move on. For question 6, it's saying the table shows that the number of kilometers Randy can run in 15 minutes. Complete the table and assume she keeps running at the same rate. So it looks like we're going 2, 4, and I'm guessing this would then be 6 kilometers. Time is 15 minutes, so what would that be in seconds? So we have to go 15 times 60, right? So let's do that in a moment. If I'm going at the same rate, if this one is doubling, then I'm going to double this one, so it'll be 30 minutes and 45 minutes. And so let's see what that is. I'm going to have to make a correction on this. I just assumed 246 was happening here, but I can see from the time of 3600 seconds that that's not the case, because that's not 45 minutes. So let's start with the top one and then work our way down. So how much is 15 times 60? Well, 10 times 60 is 600. 5 times that would be 300. So we got 900 seconds. So 900 seconds. Oh, sorry. She should be able to run. Apologies again. So 30 minutes times 60 seconds would make this 1,800 minutes. My pen's not working. 1,800 seconds, rather, for 30 minutes. So if I double that to 3,600, that means I'm jumping this to 60 minutes. And if Randy's able to run the same rate, then she is going to run 8 kilometers in that time. All right, I hope that helps.